In this video, we're going to learn how to solve linear inequalities, and then we're going to write that solution using interval notation, and then we'll also graph the solution on the real line. So let's look at this example. So first thing you want to do is to isolate x. Treat inequality just like equations, but there's one rule you have to keep in mind is when you're dividing or multiplying by a negative real number. So to isolate x, I'm going to go ahead and subtract 2 first from both sides. So that would give us negative 4x is greater than 8. And then now I'm going to divide by negative 4 on both sides. Now here's the thing you have to keep in mind. Now that we're dividing by a negative number, we're going to switch the inequality. So instead of being greater than, it's going to now turn into less than. And then we just proceed to the usual way. So on the left side, we have x, and on the right side, 8 over negative 4, that's negative 2. So that's our solution for this inequality. So if I were to draw this on the real line, the solution would look something like this. So suppose 0 is here, 1 is here. Let's suppose negative 2 is here. Because it's less than, it's a strict inequality, we're going to put the open circle at the end point, and then less than would be everything shaded to the left. So that will be the graph on the real line. And then in interval notation, we would say that our solution it's going to be less than negative 2. So that's negative infinity up to negative 2 open. So that would be in interval notation. Let's try another one. Let's take a look at this problem. So again, we want to solve for x and then express the solution in interval notation, and we'll graph it. So let's start isolating x, but before we do that, we're going to expand the right side by distributing 5 to both terms. So we have 3x plus 1 on the left greater than or equal to 5x minus 20. And then now I'm going to start isolating x. I'm going to subtract 5 on both sides, 5x, and then I have negative 2x plus 1 greater than or equal to negative 20. And then I'm going to subtract 1 from both sides. Still, our goal is to isolate x. So that will give me negative 2x greater than or equal to negative 21. And lastly, I'm going to divide both sides by negative 2. Now again, I'm dividing by a negative value. So I have to remember to switch the inequality. Now it becomes less than or equal to. And we're left with, on the left side, x. And on the right side, negative 21 over 2, well, that's just positive 21 over 2. You can leave it as a fraction or change it to decimal, whichever way you like. Now let's draw this on the real line, and then we'll write the interval notation. So let's suppose 0 is here. And if you remember, 21 over 2, it's a small number, right? So we can say, let's suppose 21 over 2 is here, and let's just suppose 12 is here. So 21 over 2 is about 10.5, and it's less than or equal to, so we close in the circle at the end point, and then we shade everything to the left because less than is on the left side. So that's the graph on the real line. Now in interval notation, we would say our solution is negative infinity up to 21 over 2, but because it's equal to, so we would put a bracket. So that would be our solution in interval notation. Hopefully this makes sense. Let's try another one. So let's try this example. So this one, you see there is 2 inequalities. So that means we're actually treating this entire statement as one statement. So whatever you do to one side, you must do to all sides. So my goal is again to replace x in between 2 numbers. So we want x to appear in the middle, and we'll just try to isolate until we get to that statement. So we want to have x in the middle, and we'll have our inequalities there probably, and we want to figure out what is it that x is between. That's how you would read this inequality. So let's go ahead and start isolating x. I'm going to go ahead and multiply both sides, all sides, by 2. So take the entire inequality, multiply by 2 to get rid of that denominator. So we do negative 2 times 2 less than or equal to 2 times 3x plus 8 less than or equal to 2 times 1/2. So I multiplied the entire inequality by 2 so I can get rid of that 1/2. Now if I proceed to multiplication, I have negative 4 on the left less than or equal to, I'm going to distribute 2, so that's 6x plus 16 less than or equal to 1. Now I can start isolating for x. So I have this statement that I'm looking for. So I'm going to go ahead and subtract 16 from all sides. So that would give me 6x in the middle less than or equal to negative 15 to the most right. And then on the most left, we have negative 20. And now I can, last thing is to divide by 6. So that would give me 20 over 6. Now, of course, we don't want to write the decimal, so I'm just going to simplify it. So we can do negative 10 over 3 less than or equal to x less than or equal to, and 15 over 6, I can simplify that as negative 5 over 2. So that's our solution to this inequality. X lies between negative 10 over 3 and negative 5 over 2. Okay, so now let's try to draw this solution set. So we have the real line. So 10 over 3, that's about 3.3. So let's say this is negative 10 over 3. And 5 over 2, that's about 2.5. So that would be somewhere here. So it's greater than negative 10 over 3. And let's suppose 0 is here. So x is between those values. So I'm going to go ahead and shade in the endpoints because they're included in between. So we'll shade in what's in between those two values. That's how it looks like on the real line. Now we're going to write this in interval notation. So our solution set is going to be bracket negative 10 over 3, comma, negative 5 over 2, bracket, because both endpoints are included. So there you have it, another linear inequality that actually has two inequalities. So I hope this video helps. That's it for this video.